Let's go to guided practice 3. Find the binomial expansion of cosine theta plus I sine theta to the fifth power. Give your answer in the form a plus bi. A and b are expressed in terms of sine theta and cosine theta. We will use Pascal's triangle to work this out. For a plus b to the fifth power equals 1 plus 5 plus 10 plus 10 plus 5 plus 1. A to the fifth power, a to the fourth power, a cubed, a squared, a to the 0 power, b to the 0 power, b squared, b third, b fourth, b fifth. Then check the sum of exponents. Make sure the sum of exponents for each term equals this 5. Then organize. A fifth power plus 5a fourth b plus 10a third power b squared plus 10a squared b to the third power plus 5ab to the fourth power plus b to the fifth power. So we will make a equals cosine theta, b equals I sine theta. So cosine theta plus I sine theta to the fifth power equals, we do know I to the 0 power equals 1. I to the first power equals I squared equals -1. I to the third power equals I squared times I equals -I. Then keep repeating. Therefore, cosine fifth power theta plus 5I cosine fourth power theta sine theta. This will be negative sine squared theta. So we get minus 10 cosine cubed theta sine squared theta. I to the third power will be -I. Then minus 10I cosine squared theta sine to the third power of theta. I to the fourth power equals 1. So we get plus 5 cosine theta sine fourth power of theta. I to the fifth power equals I to the fourth power times I, which is I. So plus I sine to the fifth power of theta. Then we will put real part together, which is cosine fifth power of theta minus 10 cosine cubed theta sine squared theta plus 5 cosine theta sine fourth power theta. Then let's work out the imaginary part. 5 cosine fourth power of theta sine theta minus 10 cosine squared theta sine cubed theta plus sine fifth power of theta I. Let's go to B. By using DeMoivre's theorem and your answer to part A, show that sine 5 theta equals this. We know cosine theta plus I sine theta to the 5th power equals cosine 5 theta plus I sine 5 theta. Therefore, sine 5 theta equals the imaginary part of this complex number, which is 5 cosine 4th power of theta sine theta minus 10 cosine squared theta sine cubed theta plus sine 5th power of theta. Check, we don't have cosine theta in these sine 5 theta expressions, so we need to change all the cosine into sine. We do know cosine squared theta equals 1 minus sine squared theta. So we get 5 times 1 minus sine squared theta squared sine theta minus 10 times 1 minus sine squared theta sine cubed theta plus sine 5th power of theta. Simplify. 5 sine theta times 1 minus 2 sine squared theta plus sine to the 4th power of theta. Distributive property minus 10 sine cubed theta plus 10 sine 5th power of theta plus sine 5th power of theta. We will do distributive property. We got 5 sine theta minus 10 sine cubed theta plus 5 sine 5th power of theta minus 10 sine cubed theta. Combine like terms plus 11 sine 5th power of theta. Combine like terms, we got 16 sine 5th power of theta minus 20 sine cubed theta plus 5 sine theta. Let's go to C. Hence, show that theta equals pi over 5 and theta equals 3 pi over 5 are solutions to the equation 16 sine to the 4th power of theta minus 20 sine squared theta plus 5 equals 0. First step, we need to solve sine 5 theta equals 0. Let's go to this unit circle, CST. Second number is sine. We need sine equals 0. This is 0. This is pi. We do know for sine and cosine, the period equals 2 pi. For tangent, cotangent, period is pi. 5 theta equals 0 plus 2k pi, or 5 theta equals pi plus 2k pi. Solve. Theta equals 2k pi over 5, or theta equals pi plus 2k pi over 5. We will use this to work out theta 1 and theta 2. When k equals 0, theta equals pi over 5. When k equals 1, theta equals 3 pi over 5. In other words, theta equals pi over 5 and theta equals 3 pi over 5 are also the solution to this function. So we get 16 sine fifth power of theta minus 20 sine cubed theta plus 5 sine theta equals 0. Divided by sine theta both sides, we got 16 sine fourth power of theta minus 20 sine squared theta plus 5 equals 0. So we draw the conclusion. Pi over 5 and 3 pi over 5 are the solutions to the equation 16 sine fourth power theta minus 20 sine squared theta plus 5 equals 0. Let's go to C2. Hence, show that sine pi over 5 or sine 3 pi over 5 equals square root of 5 over 4. We do know pi over 5 and 3 pi over 5 are the roots to this equation. Let's change this into quadratic function. 16 sine squared theta squared minus 20 sine squared theta plus 5 equals 0. Let's make x equals sine squared theta. So we got 16x squared minus 20x plus 5 equals 0. The roots is sine squared pi over 5 and sine squared 3 pi over 5. Let's use this theorem. We got x1 times x2 equals 5 over 16, which means sine squared pi over 5 times sine squared 3 pi over 5 equals 5 over 16. Square root both sides. Sine pi over 5 times sine 3 pi over 5 equals square root of 5 over 4.